Hello, students in the ASU online class SES107, A Solar System Journey. Welcome. I'm Professor Jim Bell, and I'm a faculty member in ASU's School of Earth and Space Exploration. I'm also a planetary scientist, so I study planets, moons, asteroids, comets, all kinds of stuff all over the solar system. I'm actually trained as a geologist, but I also have to use the tools of an astronomer like telescopes, like spectrometers, to do the kinds of science that I'm interested in. I'm also very heavily involved in a variety of NASA robotic space missions. So maybe you've heard of the Mars rovers like Spirit, Opportunity, Curiosity, Perseverance. I've been involved with those along with colleagues here at ASU and elsewhere, and we build and operate cameras on these amazing NASA rovers. I use these kinds of images from Mars to study the geology of the red planet and understand its past history and relationship to our own planet, Earth. You can learn a lot more about my research background and the work my students and colleagues in my research group do at ASU by Googling Jim Bell ASU or by visiting http://jimbell.cc.asu.edu. Okay, I'm super excited about helping to guide you all through this online course, which I think is pretty nicely designed to be a good, basic, fundamental introduction to the modern study of our solar system. So I think it's going to be a lot of fun. Now, what I want to do in this short introductory video is kind of walk you through the major parts of the syllabus. I want to make sure everybody's expectations are aligned here at the beginning of the course and remind you that the syllabus is posted on the Canvas page for the course. Lots of details are there. I'll be sending out announcements via that Canvas page, and I'll be updating the syllabus if it needs to over the course of the semester. So what it describes in the syllabus, and I'll just read it to you about the course, it says, this online course is an introduction to modern planetary science, the exploration of our solar system by astronomers, geologists, chemists, physicists, engineers, astronauts, and even biologists. We will study the historical and modern science of the sun, planets, moons, rings, asteroids, and comets in our solar system, and about new planets being found in other solar systems. Along the way, we'll learn about the scientific method, as well as the specific techniques used in modern planetary science and space exploration that enable us to apply what we learn about our solar system neighbors to the study of our home planet and vice versa. So, this class has a number of expected learning outcomes, 5 major learning outcomes, and I'll again just read them off to you from the syllabus. By the end of this course, students should be able to, 1, identify the inventory of our solar system, including the relative sizes, locations, and motions of the sun, planets, major moons, and major asteroid regions and cometary classes. 2, explain the theory of the formation of our solar system 4.6 billion years ago. 3, recognize and describe the fundamental processes that cause changes on the interiors, surfaces, and atmospheres of solar system objects. 4, apply their understanding of solar system exploration to explain specific planetary scale issues like climate, impact threats, and habitability that we encounter here on the Earth. And finally, 5, demonstrate how science works via inquiry, observation, verification, reasoning, and critical thinking. I love critical thinking. That's really, really important nowadays. So perhaps the most important part of this course is the textbook. Here it is. This is the Cosmic Perspective, the Solar System edition, the 9th edition of this book from Pearson Education. It comes in hard copy as well as ebook. It obviously comes in hard copy for those old school folks like me who like old-fashioned books, but it also comes in an ebook, and it's a really good ebook to be able to use because you can search very easily. It'll work on any kind of a computer or device, from a cell phone, tablet, laptop, desktop, maybe even a mainframe. I'm not even sure. You can get to the ebook from Pearson via the course Canvas site. Now, I really love this book. I've been teaching this class for many years in person out of this book for many earlier editions. I know the authors. I believe in the way that they believe students can best learn. I believe in the accuracy and the accountability that they bring to this subject. They're all professional astronomers or planetary scientists, and I've helped them just a little by providing some pictures and some reviews of various content over time in the past. So I can really recommend the text highly. Also, the textbook comes with an online tool where you'll do the homework, the problem sets. I love the problem sets. All of them are going to be multiple choice. I'll go over this all in a moment, but they also offer a lot of interactive material because it's online. So diagrams, figures, widgets you can move around and mess around with visually. I am a visual learner myself, and you'll see that most of the homework questions involve some pretty cool visuals of one kind or another. So this book is really the most important part of the class, the textbook and access to the online tool where the problem sets are done for homework. My job is to try to augment the content in this book and online materials through online lectures, which I really believe can be as much or as little augmentation as you think you need. So I've chosen the homework questions for you all to work on, the problem sets, and the kinds of problems you'll be addressing after you do the reading. And I've also put some videos together associated with each chapter. Within each of the learning materials part of each Canvas module, you'll find one short YouTube-style video, summary video, usually 5 to 10 minutes long, that covers the main topics of each chapter. Plus, you can also find a much longer, usually an hour or so, full traditional lecture that I've recorded for each chapter. The full lecture covers the same material as in the book, but also includes some extra materials on each topic that I've pulled together from a variety of other resources or personal research experiences over the years. Now, viewing the full lectures is optional, but if you're interested in lots more detail and materials and stories related to each chapter's topic, I encourage you to check them out. So please remember that both the TA and I will be available for help online or by email if needed. And more details coming on that in a few minutes. Okay, so the homework is done through Canvas in an online tool called Mastering Astronomy. It's from the Pearson Publishing Company, and it's only accessible through the course Canvas website. The Canvas site for the course is your one-stop shop. All of the assignments in Mastering Astronomy will be available to you that way. They'll be based on general concepts with lots of visuals, pictures, graphs, animations, no math problems, no essay problems. Those can be challenging, I know, but also, daunting to grade with large numbers of people in the class. I think everything in multiple choice will be fine. One nice thing about the Mastering Astronomy site is that you can try multiple times to answer each question. You lose a little bit of credit, maybe 1/3 of a point each time, but you can get partial credit by eventually getting yourself to the right answer. And it can give you hints along the way. So that's nice. There are 15 chapters of reading and homework assigned during the semester, and you get to drop your lowest score. But to do the online homework, you must register with the Pearson Mastering Astronomy site as soon as possible to do that online homework. I describe how to do that on Canvas, on the homepage for the course, and in the syllabus. So please follow the instructions to access the homeworks. If you're having problems with that, there's information in Canvas and in the syllabus about how to contact and get technical support directly from Pearson. I don't usually know how to fix things like that, so you're going to have to follow that technical support link to get help that way. But we provide lots of information for you to get that help. Okay, second important thing. In addition to the homework, there are also laboratory activities for this class. The class has both homework and labs due most every week. There are 6 required online lab activities and 1 bonus lab activity in an online platform that's called Argos. Argos is a really cool platform, and students have really liked these lab activities in the past. But again, you have to register in the Argos site as soon as possible to do the online labs. You can only access the labs through Canvas, through the Canvas course site. And when you try for the first time in lab number 1, that's when you'll have to register in Argos. And just like for the homework site, there's technical support available for the labs if you need it, and I'll get into that topic in a bit. Okay, what I want to go over next is something called the course planning map, which is appended onto the end of the syllabus. You take a look at that and you can see that it lists for each week, each module, each topic, the objectives, the assignments, the materials covered, as well as the due dates. They're listed there week by week. So week by week, what are the assignments? What are the chapters you need to read? What are the homework sets you need to complete? What are the labs you need to do? And what are the deadlines? Deadlines. Remember, deadlines. Some weeks are full weeks and some weeks are half weeks, so please pay attention to what is due when. Here's something else important to know for this course. Late assignments are not accepted without an official university accommodation. If there's an emergency or some other extenuating circumstance that causes you to miss an assignment due date, please reach out to the official ASU offices and programs listed in the syllabus so that they can contact me about an extension. Extensions or incompletes cannot be granted without that official university accommodation. So please consult the syllabus about what to do if you have to miss an assignment. Similarly, please also consult the syllabus if you need an extension based on the observance of a religious holiday or based on your participation in specific university-sanctioned events or activities. If you follow all the rules on this, the TA and I will be able to work with you to help you stay on track and get caught up. The biggest problems, frankly, that occur each semester are because students haven't read, understood, or followed the rules that are laid out in the syllabus. So please take the time to read through the syllabus carefully so you understand the expectations for this course. Okay, so in the first week, in Module 1, you're going to get yourself registered in Mastering Astronomy in order to start the Chapter 1 homework. And I recommend you also open Lab 1 so that you can get registered in the Argos website, even though Lab 1 isn't due until a week later. And then after that, every week, there's usually 2 chapters assigned for homework and usually 1 lab. Please note the due dates, module by module. And importantly, all of the homework and lab assignments are open on the very first day of class. You can start them anytime you like, but they all have different due dates as we go along. Homeworks and labs are due every Sunday night by 11:59 p.m. Arizona time. That's every week in this class. All of your assignments and due dates are known now, right now. So please plan to meet those deadlines. It's a compressed schedule because of this short semester 7.5 week format. So please keep up with the class. Okay, so content-wise, we'll go through the entire solar system. You'll learn about the sun. You'll learn about small bodies, asteroids and comets. You'll learn about the planets, large and small. We'll talk about the terrestrial planets. We'll talk about the gas giant planets, the ice giant planets. Wait, what does that mean? What's an ice giant? You'll learn about that. We'll also talk about planets around other stars. There's a whole chapter dedicated to that. And this is a brand new, exciting field of astronomy. And then finally, we'll talk a little bit about astrobiology, the study of life in the universe, life on Earth, and the potential for life elsewhere in the galaxy and beyond. I think that's pretty cool stuff. I think it's great, fun, interesting set of topics. We'll cover most of the solar system textbook. As you can tell, there's a lot of work. We're cramming a bunch of work, a whole semester's worth of work into this 7.5 week short format. So you're going to have to put some time into it. What kind of time commitment is expected? Well, I know everybody works at a different pace, but I'm sort of typically expecting every student to probably spend 1 or 2 hours just reading each assigned chapter, maybe taking notes, maybe highlighting. Then I'm expecting it'll take roughly 30 minutes to an hour to work on each homework assignment, and maybe half an hour to an hour to work on each assigned lab. It's a lot of material to cover, and we don't have a lot of time. We're cramming it all in, so please don't fall behind. Please keep up with it. It's a 4-credit course, and it satisfies the SG science requirement for ASU undergrads, so I'm expecting you to put the hours in. Okay, let's talk briefly about grading. This is all in the syllabus, but I just want to briefly go over it here. Your grade will be based on 2 components. First, homework, and second, labs. Homework will be 70% of your grade, and labs will be 30% of your grade. So over the course of the semester, you're going to get those 15 homework assignments based on each of the chapters that you're reading. They're all multiple choice assignments, like I said before, and they're associated with each specific assigned chapter. And there are links between the homework questions and the ebook version of the textbook. And that's partly why I recommend you go with the ebook, because it'll really help while doing the homework online. Every homework assignment, each one is worth 5 percentage points, 5% of your grade. You're allowed to drop one out of those 15. Maybe you're sick part of a week, or maybe you can't catch up on it by Sunday night, or whatever. So you can drop your lowest score. That leaves 14 that you'll be graded on times 5%. That's 70% of your grade. Now, the lab activities. There are 6 of them that are required, 6 required labs. They're all open for working on at the start of the course here, and they're all due starting in the second week. So there's 6 of those. They're also worth 5% of your grade each. So 6 times 5 is 30% of your total course grade. Now, for each lab, it's important to note that you're only graded on completion of the questions and activities. There are no points for correct answers or loss of points for incorrect answers. You just have to go through it. In each section of the lab, you'll be asked to do some activities and to answer certain questions. If you get the question wrong, it'll give you some hints and you can try again. So it's good that way. There's lots of great graphical demos and some virtual field trip kind of activities built into these labs. If you stop halfway or you run out of time halfway because you waited till a half an hour before the deadline to start the lab, you'll get 50%. If you don't do a lab at all, that's a 0. Now, there's also one bonus lab, number 7, at the end of the semester. If you do the bonus lab, you can use that score to replace your lowest score on the other 6 labs. And if you ace all 6 of the earlier labs, 100% completion, you can use your bonus lab score to get a little extra credit at the end. You can see this section of the syllabus called Grading Policies for all the details about homework and lab grades. Letter grades will be given on a standard grading scale, and I've listed the standard letter grade boundaries in the syllabus. There could very well be some curving of the grades depending upon the performance of the class, but the letter grade boundaries won't be raised compared to what's shown in the syllabus, so it can only get better. So check that out and let me or the TA know if you have any questions on the grading or the assignments. Okay, now I have a confession to make to all of you. My confession is that teaching an online class is a relatively new thing for me. I used to teach this class in person. I love teaching it in person for a variety of reasons, but I know that online classes are very popular these days and also super convenient for many students who have day jobs, families, or other specific circumstances that make enrolling in in-person ASU classes on the Tempe campus difficult or impossible. So you're all part of an interesting experiment for me in my teaching career. I've been actually wanting to offer an online class for some time, but I have a lot to learn on the technical side, on the educational side, and I'm going to rely on all of you to provide me and the TA with constructive feedback on what's going well and maybe what's not going so well. There are several ways to get us that feedback. I've set up, for example, I've set up a special Gmail account just for this class. That Gmail address is listed on Canvas and in the syllabus. And I've set it up in Gmail because I get so much email every day to my regular ASU address that if you send me a message that way, it could easily get lost. Also, I rarely get notified if I get an email via Canvas, so that's not a particularly reliable way to reach me either. So please use the Gmail address to best reach me and the TA. There's also a chat-like tool in Canvas. It's called Community Forum. You can message me and the TA or each other using that tool as well. And you can find the Community Forum link from the discussions menu on our Canvas homepage or from the link near the bottom of the Canvas homepage for our class. Note that the TA and I have set up live office hours online using Zoom twice a week. Our office hour days and times are listed in the syllabus and on our Canvas homepage. Now, during office hours, we can help with homework or lab questions, questions about the reading, or maybe just, hey, what's going on Mars this week, Professor Bell? whatever, that kind of thing. If you can't attend any of the office hours that we offer, then please send us an email and one of us can arrange to meet at another time that we can arrange together, online or on campus. So please reach out that way. A common reason that students reach out in this class is because they're having some technical problems with the homework site or the labs. If you follow the instructions in the syllabus and the announcements in terms of browsers, how to navigate the labs, what to do if certain common problems occur, then hopefully you won't have any technical problems. But if you do, odds are that neither me nor the TA can fix it. So please carefully read the homework, lab, and technology support section of the syllabus to find out how to contact the right support people at Pearson or at Argos to get help. But please know that technical support is likely not going to be available on the weekends and definitely not in the late hours on a Sunday night just before the assignments are due. So please start the assignments during normal Monday through Friday work week hours, typically 9 to 5 in Arizona, so that if you need technical help, you can get it before the due date. I'll be sending Canvas announcements to all of you each week outlining the next assignments and maybe other fun astronomy or planetary science topics that come up from week to week. So please look for and read those announcements for important information. Okay, I think that is a basic introduction to SES107 and a basic walk through the syllabus. There's lots of other important information in the syllabus like a reminder about ASU's academic integrity policy. Simply put, please don't cheat because you're likely to get caught and get in a lot of trouble. If you get to the point where you think you need to cheat in order to do the work or catch up, please reach out instead to me or the TA or to ASU's Student Advocacy and Assistance Office and let us try to help you get through any tough times, please. All right, I'm sure you all have questions and you can find many of the answers on the course Canvas page and in the syllabus, so please read those resources carefully. I'll be sure to circulate that special Gmail address to help answer those questions as quickly and as early as possible in the semester. Finally, I want to thank you for enrolling in this course. I want to thank you in advance for your patience as I figure out how to best offer you an online course. I'm a professor and a researcher in planetary science, but I also consider myself a lifelong learner, maybe like you. So I really hope that you're as excited to learn about the solar system as I am. Thanks, and I'll see you again real soon.